Provide the missing product or starting material for the following acid-catalyzed reactions. You might need to provide more than one molecule in certain instances. All right, so these are a little bit tough. I wanted to give you guys some harder problems just to get acclimated to something that you might see on the exam. Let's make this a little bigger so I have more room to draw. All right, so here we are under acidic conditions and we're making an acetal, okay? Is it a fancy acetal attached to some things that might look a little scary? Maybe, okay? But it's an acetal, and all acetals come from carbonyls, all right? So you identify the carbon that has two heteroatoms attached to it, which I've done here in red, all right? That was a carbonyl in our starting material, all right? So I'm going to draw that carbonyl. Okay, so we also know that this came from alcohols, right? This bond and this bond were formed in the formation of the acetal, and those oxygens came from alcohols. So what I'm going to do is I'm going to draw those alcohols out right here. All right, we know that this alcohol is attached to that. All right, so what is our carbonyl carbon attached to? So I'm going to highlight this in red. This is our carbonyl carbon. All right. So that is attached. We're just going to draw it exactly the way it is in the picture. All right, that was drawn to a carbon that went to an OH. That was drawn to a carbon that had an OH on it. All right, that went to another carbon with an OH on it. And that carbon was attached to a carbon that has the oxygen that has that alcohol that was in the acetal, and we're done. Okay? It's literally identify the carbonyl carbon, all right? Identify where those oxygens had to come from. They have to come from oxygen, and then you just figure out how it's all attached, okay? And it's just follow the picture, all right? And if it makes you feel better, we can also put a hydrogen on the carbon here, all right? Because there is a carbon right there. It's just not drawn on the structure, okay? So sorry, I am writing this in with my finger on my iPad, so it's not the most precise, but again, I hope you get the idea. So, next question, same principle. All right, now this is an acetal again, but it's a mixed acetal, which means that it came from two different alcohols. All right, so again, which carbon has two heteroatoms on it? The one I've highlighted in red. All right, so we know that this oxygen had to come from an alcohol. We know that this oxygen had to come from an alcohol. All right, so I'm going to draw the carbonyl. All right, there's also a hydrogen that's not drawn here, so this came from an aldehyde. All right, now that carbonyl carbon was attached to a carbon, which was attached to a carbon, which is attached to a phenyl ring. Okay, that phenyl ring also has one of the alcohols attached to it. All right. So that was one of our alcohols that gave us one part of the acetal, and the other one was given to us. Methanol is part of this, so you didn't need to add methanol into your conditions. All right, and of course, you don't want to leave off the ketone that's hanging out off of the phenyl ring. All right, but again, where is the carbon that has two heteroatoms on it? That was a carbonyl in the starting material. All right, and the two oxygens that were attached or are attached to the acetal carbon, they both came from alcohol. So you just draw that line. You could even just draw the line and put an H on the other side of the line to remind you that there's an H there in the starting material. All right. This next one is tricky, but I do give you a hint here. So you have chemical formula there. We have chemical formula here. So we're going from H18 to H14, so we're losing 4 hydrogens, and we're going from O6 to O4, so we're losing 2 oxygens, so we are losing 2 waters. All right. Now in this case, we don't have an aldehyde or a ketone, so this isn't going to be an acetal formation. We have carboxylic acids and we have alcohols. All right, so this is going to be a double Fischer esterification. All right, so this OH group is going to end up leaving. This OH group is going to end up leaving. Okay, and these OH groups are going to end up forming bonds with the carbonyl carbon. All right, so here we have 1, 2, 3, 4, 5, 6 atoms that will be in a ring. Okay, same thing goes here. 1, 2, 3, 4, 5, 6 atoms will be in a ring. And so this ends up being this diester. Okay, cyclic esters are called lactones. All right, and of course we've lost 2 equivalents of water, 1 for each Fischer esterification. Okay, and the last question on this page is here we have a carbonyl and we have a diol. Under acidic conditions, the carbonyl oxygen is going to leave as water. We're going to form carbon-oxygen bonds with each one of these oxygens. They are tethered to each other, like so, and they have methyl groups on each of those carbons. And so we're just forming a fancy acetal with those methyl groups. Alrighty.